talk about is how to solve this graphically. Let me get rid of a lot of this. So let's say I have a graph that is the person's position and the person's time. So remember, any graph you make is going to need labels for the axes. So I'm going to say position in meters, so don't forget your units, and time in seconds. You'll probably want a title so we know what we're looking at. So we may say position of stick figure for a given time, whatever you want to say. And let's go with increments of 10. Now remember, your increments need to be consistent. And let's try and move all of this down. We can have a 60 up here. That's not even close. That's why we use graph paper. Okay. And on the bottom, let's do increments of 5 seconds. As a rule of thumb for graphs, try to use up the majority of the space you're given. So let's say this is the space you're given to answer a question. Your graph should extend past the halfway point in both directions. So whatever you have for your best fit, it should extend past halfway on both sides. So we can see here, if this were my graph, it has used up all that space. So this will help make sure that your graph is big enough so you don't lose the shape of the graph. Because I mean, if we zoom out enough, everything's going to look like a line or a dot. So try to use up as much space as you can, make it nice and big. Alright, let's keep track of where this person is going to be. So if they run 6 meters per second for 5 seconds, that should be a distance of 30 meters, so they'll be right about here. 5, crap. So 5 meters for another 5 seconds. Should be another 25 meters. Be at about 55. Then for 1 more second, the person's at rest. And then at 15 meters, or sorry, at 15 seconds, we spend 4 seconds going back at 1 meter per second, so that should be 4 meters back. So we get something that looks like this. And so our distance, if we add them all together, will be 59. However, our displacement, if we add all the vectors together, would be 51. And you may notice here, if we take the slope of each segment, we'll get the velocity for that segment. Whoops. That should be 51 minus 55. Meters per second. Your slopes do have units. So if our slope can represent the velocity, if you imagine a line from start to finish, if we find the slope of that line, that should be the average velocity. So in that case, 51 meters minus 0 meters over 15 seconds minus 0 seconds, and we should get a positive 3.4 meters per second.